Hello? Okay. Yeah. So yesterday we discussed about the keep and drop options. So these are the two majorly we use number of variables. How many number of variables that you want to use it and how many number of variables that you want to process it. So these majorly used to whenever the data set has very huge number of variables or columns in the data set level. So this will be very useful because to limit the number of columns, whenever you limit the number of columns, automatically the data size will also be reduced. The processing time, like the execution time, will be increased, like the decreased automatically. So in those point of view, majorly we use these are the two data set options, as statement or options. Again, if you use these data set option at input data set level, means whenever you're reading from the data set level, then it means it will be very it means it will improve the very performance very well compared to when you are using that output level. Okay. So these may be used as a dataset option as a statement. If you use the option after the dataset, then we call it the dataset option. If you use as a statement, then we call it the statements. Yeah. So then other option here is rename. So rename is nothing but is majorly used to rename the variables. Suppose you want to rename one variable to other name. So instead of changing, like instead of keeping that name, I want to keep it a different name. Then the syntax is rename old name equal to new name. So this can be used as a dataset option, as a statement, both. So if you look at here, this is a variable. This is a dataset. I want to rename this to because it's a type of mistake is there. I want to rename this variable. So this is how I'm going to use as a rename option. See, it's a dataset name at output level we are using, not at the input level. So you can see this now. So we change it to rename this option. So this is how we can use it. So the same thing can also be used as a dataset. This is how we can use it. Old name equal to new name. This is called as a data set of it's a statement. Yeah. And the next one is because till now we discussed about the how to control the number of variables, like at input level and output level. Now you are controlling the observations. Nothing but so how you can, because suppose if the data you receive the data set or you're in the databases in database the data set is very huge. It's like around 110 GB data set is there. Your manager asking to read the data set and create the report. But it involves very huge business logic. You have to write multiple steps in that. So whenever you're writing some business logic, some small logic, you want to test that logic into the data level. Whenever you want to test that logic in the data level, you don't need all the 10 GB data at every time. What happening is if you are testing 1 GB, you have to run it and you have to wait some time and you have to see the results. Instead of that, take some 100 records or some 100 observations from the data set and test the logic. If it's successfully done, then remove that particular limit of number of observations. Then what will happen is you can write the logic instead of waiting for waiting for execution and see the results. Then you can write within a second, like within 10, 15 minutes, you can write complete program and see the results. So it means whenever you're reading the data, whenever you're creating that kind of report, apply the business logic, the data set is very huge, these options are very helpful. Like controlling the how many number of observation that you want to read. Okay, so so these are the two options. Like OBS is nothing but observation. First OBS is about first observation. So when you say OBS means how many number of observation that you want to take it. Okay, so when you specify the certain number, by default will take those many number of observations from the data set and read the data and apply the business also can see that. So this is our OBS equal to 25, nothing but observation equal data set option the set statement stops reading the observation in 25. Up to 25 it will take it. The automatically it will start data from first observation onwards. Now you want to control, like suppose what happening is by default, so you receive the data set. But in the first standard observations, everything is data is perfect and everything is good. Then whatever the logic that you applied, it's everything is working fine. But after certain number of observations, certain number of records, the data is not properly there, not present, or not correctly read. So in this case, what happened? You have to test the randomly also, right? So it means you have to take randomly some observation in middle of the records. Like from out to 1 to 1 million records, you test only first standard records, everything is good. But I want to see middle of the data. Randomly, I need to pick some number of observation and test the logic if it's working fine or not. So in those cases, what happens? You have to use the first obvious option. So when you specify the first obvious equal to, it means from which observation you're asking to read the data, and from which observation to and OBS, if you specify OBS, it's the last observation. It means from which observation to which observation, like you have to take it. Like I want to take the data from 100 to 120 records. It means only 21 records I want to take it and test the data. Or you can specify any number. It means by using this first OBS and OBS option, you can randomly select the number of observations, set a number of observations randomly, and you can test the logic. If this logic is perfect for any number of records for any way, for any record, that means automatically the logic will completely work with the complete data. Then we can remove these particular options. So these options majorly used whenever you are developing the code, whenever you're writing the code to generate some report like kind of thing. Okay. So once the program is done, once everything is done, so you have to remove this option. These things often you have to remove in the program level. Otherwise, what happens if you move it to production, it will be very tough. So it will be limited data, the results will be wrong. So any questions on these two options? Rename or first obvious or obvious? Okay. Yeah. Yeah. So there is another option called another statement, retain statement, like how keep statement, drop statement, rename statement. Similarly, we do have another statement called retain. So retain nothing but it's preventing the means whatever the value is there that will be reinitialized into the next record for the new variables. Like the retain statements prevent SAS from reinitializing the values of a new variable at the top of the data set and can be used to create accumulated totals. So what do you mean by accumulating totals? Means you want to add the second observation, first observation amount to the second observation like that. So this is how we can use it. Sales amount and amount. So this is when you accumulate the totals 498, 144 like this. So to create this kind of output, then you can use the retain statements. How to retain? So initially, what are the variable that you are going to create? That amount will take as a 0 and add that particular amount. So this will create a cumulative total for that particular amount values. So So in here, previously, the previous values of the return variables are available for crossing across the iteration of the data set, majorly in this particular functionality. The return statement resizing return variable to missing before the first execution of the data set, which is not specified. It means, so initially, if you want to specify some amount like zero, initially by default, it's if you don't specify it by default, it takes zero. And if you want add some initial amount to the particular amount to values, then you can specify amount. That amount will be added to the complete observations. So return also used to reorder the variables in the data set means this method is used to how can reorder the data. Nothing but I have the variables in the 1 to 10, but the fourth observation I want to keep it in the second value, second column, and fifth observation I want to keep it at ninth position in the order of the columns, the data output data set. Then that particular use will be used. So these options will be used. So the next topic we are going to discussing is, so this is also one of the important topics. Here we are writing the data, SAS data set to an external file. So in previous classes, what we discussed is how you are going to read the data from external file into the SAS system, into creating the SAS data set. Now in this particular opposite, from the SAS data set, we are going to write the data to the particular file. So here through data step, you can write the file to a .txt file text files or .csv files and .dat files. Only these are the three different type of files you can create it. Now you cannot create .csv, .xls, any kind of other files. It's a data step I'm saying. You can do other methods, you can create it. But with the SAS data step, you can create only three different type of files by using the SAS data step. Okay, so this will be very important topic. Like, so can you explain? Can anybody tell me that what are the when you are reading the data, what are the two different statements that will use it? So whenever you are reading the data, so after the data step, there are two different statements that we used. Anybody remember that? Two statements, two important statements that we used to read the file and create the variable. So we used in file and input, right? So we used in file and input statement. These are the two statements majorly used to read the data values from the file. So opposite to that is to write the file is we used file statement and put statement. We removed in keyword and we used put and file statements. So these two statements majorly used to write the data values from SAS data set to the particular file. Okay, let's go to the example. Yeah. So this is my data set. Here we have the name, sex, age, height, and these are the 5 different columns, 5 different variables. I want to create a text file, means I want to export this data to a text file. So if you want to any delimiter, you can do that. If you don't want any delimiter, that's good. So let's try a couple of options, different things here. So data, so temp that I'm using is SAS help library, class data set. Okay. Let's look at the data here. So we use this one. Okay. The first statement that we are going to use in the while reading is in file. Similarly, here we are going to use file statement. So whenever you're going to use the file statement, you have to specify where you want to create the file, where you want to create the particular file, and what kind of file that you want. So I want to create the file in this location with the name called class.txt. Okay. The next step we discussed is put statement. So whenever you specify the put, means you have to specify what column that you want to write it. Name, age, age. Go there and see that. You can see the file with the .txt. See here, by default, it's created a space delimiter file. So as you know that by default, the delimiter in SAS is okay. So here default delimiter is space delimiter. So now if you want, you can change the delimiter to different delimiter. So that is whatever the delimiter that you wanted. You have to specify the delimiter here. So if you run it, the file will be cleared in the default delimiter. Change it to comma. But if you look at here, by you have the data, but you don't see any column header, right? So this particular name is representing to what? This particular data. So, so if somebody new, if they don't see that what kind of data is it, they're not able to understand. If you have the column names representing the particular data, then you can easily understand that. Okay. So now it means you need to add a column header to the particular file. So the column header is always in a top position, like means first row, right? So to add the column header, we need to learn couple of options, couple of other things like there is a underscore n underscore. So this underscore n underscore is representing the row number in the output file. Or like what is the observation number in the data set level? Okay, suppose here we have 19 records. It means maximum n is underscore is 19 only. So underscore n is nothing but it's representing the row number in the file in the data set. So if it's underscore n equal to 1, it means what I'm saying is if particular underscore n equal to 1 means if it's a first observation, if you're writing the data at a first observation level, I want to do something. Then what I want to do, I want to put the header. So to put the header, you have to use the double quotations within that. So in this case, what happens? You have to whatever the column name that you have to copy paste. That means you cannot write by write. You have to manually copy, manually specify those columns in the put statement. So if the file has a delimiter, then you have to enter the delimiter like this. So if n equal to 1, then write it. Or else, if not n equal to 1, then whatever the columns we have, you can write it. So then just run it this and let's see. See. So there are only 19 observations, but in the file you have 20 records. You can see here. It means whatever the name, whatever the character that you have specified in the put statement, those will appear here. But normally, whatever the column name that you have used, you have to just copy paste those column names. Whatever the names that you have specified, these column names you have to copy paste. It will be easy because whatever the order that you specified here, that order only the data will be written. Suppose if I change like this, it will be also changed. The data also will be over, as you can see, height and weight. It changed the values. But if by looking at this column header, somebody is saying it's height, right? So it means whatever the column name that you specified in the put statement here, that same column that you have to specify here. So in this case, like when you specify like that, it will be representing correctly in the output file. Okay. Now we learn about the underscore and underscore. Similarly, there is another option called underscore error underscore. So that will tell you that if the particular observation number is processed successfully or not. So like whenever you're reading the data, particular file or writing the data particular file, as per the specification that you define in the input statement or put statement, if the data is there or not. If anything is there, like suppose you specify a character, you can able to read it. But if you specify that particular number as a character as a number, then you cannot read it because you will see the missing. And if any missing data is there in between the data at end of the data, then that particular record will be the record number. Let's try that maybe here. Yeah, let me give you the couple of examples then. You can see here. First observation, you don't see any issues. You can see the observation number. It means while reading the data at the second observation, you have some issues. How you will know that if the particular observation is missing, you have some issues means whenever you say underscore error underscore equal to 1, it means in this particular observation, as per the syntax that you define, is not reading the data properly here. Which variable is not reading properly? You can see employee ID. You can see dot. So if the particular ID has issues, then you can this in the log file that will show you that in which observation you have issues on which variable you can see that here. But this it's not possible for if you have number of variables, but you need to understand that which observation you have the issues. Okay. So this underscore error underscore equal to 1, it means you have something is not correct in that particular data record, the row. If everything is correct, if underscore error equal to 0, then the data will be written to the output file. If it's error, then it will not return to the output file. So these are the two variables, automatic variables that will be created in the back end. Okay. So those are the options majorly we used. Okay. And there is one more thing here. So you are reading the data from the SAS help some data set and creating the file, right? Do we really need this particular data set here? Got what I'm saying? Because you already have the data set and the data set you are asking to write it. But again, why you need to create the new other data set here? It means the data set is not mandatory, right? So to avoid these kind of things, we use the underscore null underscore is another data set name. Is a dummy data set name that we can use in the SAS. So by using the underscore null underscore keyword as a data set name causes SAS to execute the data set without writing observation to the data set. Okay, so these are the things like underscore null underscore is sometimes they will ask the question in interviews, what is the use of underscore null underscore? So it will be used to process the data without creating the data set, without creating the SAS data set and to execute the SAS code. So underscore and underscore variable. These are the automatic variable underscore n underscore error and this numerical character all. So this will coming classes. I will explain it that what exactly these purpose. Majorly this will be used in arrays. I'll explain it that. Yeah. And there is another option called end equal to option. So what exactly it's saying that is you are asking this particular observation is lost observation or not. And means that the observation is lost observation. So this creates and names a temporary variable that acts as the end of the file indicator. Okay. So to determine if the particular current observation is a lost observation or not. So where you will specify means with this option will be specified in the set statement. End equal to this last is a temporary variable name. So you can specify anything. You can specify any variable. End equal to. So last is the word that last is a variable name that I am using. You can use A, B, anything. But that variable will be used at the bottom. If last equal to 1. So when you say 1 means that particular observation is last observation you are saying that. If it's not a variable, so initially it's 0. If the particular observation is not a lost observation, the value is 0. If its observation is lost, then the value is 1. If the value is 1, it means that is a lost observation. I just want to write something at the bottom of the file. So that's the major attention here. If last equal to 1, then you have to put something at here. Okay. It means after the last observation, if I want to type something, anything here, there is a last observation like this, then you have to use end equal to end equal to option. Any questions here in this file and put statement and options? These are options. Because this particular thing is very useful. So whenever you want to create a file without anything, just simple as export the file. Good. No question. Good. So with reading the raw data, we just saw that in previous classes how you can specify it. Yeah. To complete all these things. Yeah. So before going to the SAS functions, so we can go to the other thing is called the do loop and arrays. So we can discuss that one now. SAS loops. So we call that. So how we can going to use loops in SAS by using the do loop. do an arrays, we can create the loops and we can process the data in the loops. So first we'll discuss about the SAS do loop. So here we are going to be discussing about the main objective is how to understand how like iterative do loop, how you can, because so even though if you don't have any data that you're going to read from the file or manual entry, you can create the data set with using the do loop. So that we'll discuss it now. Yeah. So how you can generate the data with using the do loop, and how you can by using the do loop you can means you can reduce a lot of code. It means you can remove unnecessary code, eliminate redundant code. The do loop processing you can conditionally execute the fast code. So by if you want to execute this code based on a certain condition, then you can use a loop, do loops. Yeah, let's take this example here. So this is my some coding. So let's see how we can do the reduce the redundant code. There is amount. So compare the my scenario is compare the interest yearly versus quarterly compounding of 50,000 investment made for 1 year with the interest of 7.5. How much one money will earn in accurate need situation? So my question is, if you are investing $50,000 and every year, not only for 1 year, with a constant interest rate of 7.5. So what is the total amount that you are from between the quarterly and yearly? How much will be increased? Or how much amount will be? If you calculate on year wise, if you calculate on quarterly. So here amount is 50,000 and rate is 7.5 minus 0.075. So when you do the calculation on yearly, you will get directly, you will get amount into rate, you will get the amount, yearly amount, how much interest rate you will get it. But similarly for the quarterly, you need to calculate each and every quarter, whatever the amount that you received in the first quarter, that will be added to the next quarter. So it means you have to write 4 different quarterly statements. Each quarter you have to write a different quarter statement and do that. So this normally will do that with the programming without using any do loop. The same thing if you want to use a do loop, so then just use a do this particular quarter and create temporary variable quarter called 1 to 4. And the same statement if you execute 4 times, then automatically you will get the yearly quarter, each quarterly amount. Yeah, any questions here? If this logic is clear, you are able to understand, you want to execute and try to show that. Okay. Yeah, I'll show you that how you can write it. Yeah. So interest initially the amount is, when you run it, you'll get the yearly amount. Yearly how much you will get interest. But if you want to execute each quarter, you want to calculate each quarterly, and that first quarter amount will be need to add it to second quarter. Then you have to write 2 quarter. So this PTR is a temporary variable. Okay, so you can use any variable, not only quarter. You can use I, J, or any letter. So what is the starting position? It means I want to write 1 to 4. It means I want to execute this particular statement 4 times. So every time you have to increment by 1 automatically. So then you have to use what is the quarterly amount. rate. What is the rate? What is the calculation? It's like the quarterly plus amount is the rate. So whenever you start with the do loop, you have to end with the end statement. So for every do loop, you have to end with the end statement. So this is about how you can write the formula. So if you do execute it, then you can get the, it is after 4 quarters, what is the amount. So it means if you increase, if you use the quarterly, the amount will increase around $156 when you compare to the yearly one. Okay. So this is how you can use a do loop. So here by default it incremented by 1. So let's see what exactly it will do that. So the iterative do statement, like how we can write do the index variable, what is the specific start variable, specifications, and additional statements. So this is how the syntax is do index variable 1 to, that is start variable, to top variable, value by increment. So if you specify what is the value is there, that increment by. If you don't specify, by default it is increment by 1. So let's take a couple of examples here for the numerical variable. When you say do I equal to 1 to 12, so it will execute the loop for the 12 times. When you come to the start it will come out of the loop. So it means out of the range, then it will start executing the loop. Similarly, there is another example. So if you specify 2 to 10 by 2, meaning every time it increments by 2. So this is minus 2. So it means that the amount will be decreased. The value of the value will decrease. So it's like in 0.05, it also changes. So what are the values of each variable? So I can see here. So this is about the numerical. But what about the character? How it will be execute the loop for the character value? So how many times will the loop? So let's see that if it's a character, it will execute the 3 times, like January, February, March. Individually, it will execute it. So when it comes to the numerical values, it's by increment or decrement will do that. But when it comes to character, how many values that you specified in that particular value, in the loop statement, those many times will be executed. So this is executed 7 times. This is executed 3 times. But it doesn't mean exactly how many number of times, because depending upon your begin date, the value will be executed. A certain number of times it will be executed. And here it's only 1 time, because it's subtracting this particular test1 minus test2 value, and if the numbers are there, it will do that and execute only 1 time. So this is how it will, the do loop will be executed for the character values. For the numerical, it will be subtracted. For character, the number of times the number of character variable that you specified, those many number of times it will be executed. So this is how it will execute the loop. Yeah. So any questions on the previous scenario? We'll move to the different scenario on that one. So here there is another scenario: perform the repetitive calculations. So on January 1st of each year, you are investing $50,000 in an account. Determine the value of the account after 3 years based on the constant interest rate of 7.5. So every year you are investing an amount. The constant. What is the amount value after 3 years? So it means you have to run the loop 3 times, 2001 to some certain number of times. Means 3 times you have to execute the loop. Since it's year mentioned, so you have to take some year value. Initially, the capital amount we are considering as 0. 0 plus 50,000 means initial amount is 50,000 or 5,000, and the amount will be added to the for that particular amount, and each year you want to calculate the interest. So capital amount into multiplying interest, so you will get the yearly interest. That yearly interest will be added to that particular principal amount, and will go to that amount will be passed to the next year. So like this, it will be executed 3 times. Let's see this. So initially, the PDB value is missing year and capital, and so when it comes to the year, capital amount will be 5,000, and the capital amount will be calculated and go to the next year. So like this, it will be check for all the certain number of years. If the loop is out of range, then it will come out of the loop and we'll start writing the data and show the output. So see here. But if you see here, because it's 3 times only executed, but it got seen in 2004. It means in the 2004 beginning of the year, because we took the 2001 as a beginning year, right? Similarly, we took the 2004 as the beginning year. This is the amount for that particular amount will be the principal amount after adding the 3 years. So I'll show you one thing here. 3 times. So our amount is 5,000. So how much interest? Compound into 7.5. 0.075. So you will see fourth year, you can see like this. But I want to see each and every year you want to see the results. I want to see each first year how much, second year how much, third year how much. If you want to see that like the amount like each quarterly, then you have to use output statement here. Yeah. So if you see here, if you look at here the data, now you don't see any fourth year because it's out of range. Each and every year it's how much. For initially it's 5,375. Next year it's much probably like this. Since if you specify output here, the data will be written to the output data set. Each iteration time. If the observation is 1, the amount will be written like this. And the first year, what is the compound amount? This one, like this. So means so if you just use this one, then automatically the output will be written to the each and every iteration in the output file. Is it clear? The output statement. So yesterday also we discussed about how we can use output statement. Generate a separate observation for each year if you specify output. Yeah, so this is also one of the example. So each and every year you have to calculate like without writing any without using the do loop, how you can calculate it. But if you use a do loop, so simply you can write it here. Yeah. So any questions here? So we'll continue this iterative do like a conditional iterative. So we'll start tomorrow with this other topic and we'll continue arrays. So mostly we'll continue do loop and arrays tomorrow. We'll start a new topic tomorrow. So we'll start with the function. Yeah, maybe tomorrow I'll try to join at my home, so there is no internet issues. Okay, so we'll meet tomorrow again. Yeah. Thank you.